Hello everyone, it's Chapter 3 Binomial Theorem by iTunes Academy. Binomial just meaning polynomial with two terms. Okay, let me write that. So, binomial is polynomial expression with two terms. Okay, if I have x plus y, this is a binomial expression in first degree. Okay. Again, if I have x plus y square, what is the expansion of this bracket square? This will be equal to x square plus 2xy plus y square. Okay. Again, if I have x plus y and this bracket power 3, okay, the expansion of this bracket equal to cubic x plus 3x square y plus 3x y square plus cubic y. If I look here from the power 1 up to power 3, the coefficient of x and y, or the first term and second term in these brackets. Let me write that here the coefficient of x is 1. Here the coefficient of y is 1. Here coefficient of x square is 1, and here the next term is 2, and the next term is 1. Again, in the last bracket here, the first term has coefficient 1, and the next has 3 and 3, and the last one has 1. Okay, if I look here, 2 here is in between 1 and 1. Okay, and here 3 in between 1 and 2. Here 3 in between 2 and 1. So the number in between two numbers in the previous row here is equal to the sum of these two numbers. Okay, let me continue. If we write here 1, okay, here we write 4 is sum of 1 plus 3. Here let me write 6, okay, is sum of 3 plus 3. Here 4 sum of 3 plus 1, and here is 1. So if I need to expand this bracket here, power 4, this will equal to x of power 4 plus 4 cubic x y plus 6 x square y square plus 4 x cubic y plus y power 4. Okay, and this is named Pascal triangle. of coefficient of binomial expansion. Okay, and here if we need to continue here to power 5, here 1, okay, 5, 10, 10, 5, 1. Here I can continue to any positive power up to n. Okay, and let me generalize that. If we have x plus y power n, and in here is positive integer number, and this is our first case of a binomial bracket with power positive integer, and here is greater than or equal to 1. Okay, if I need to generalize my binomial expansion, okay, this will be equal to sum of n combination of r minus 1. Here x, the first term here is x, so it doesn't necessary to find here x, just x here represents the first term. Okay, so x of power n minus r plus 1, and y here which represents the second term, okay, with power r minus 1. And let me rewrite this here. N is greater than or equal 1, and r represent number of any term of my expansion. So r here start from r equal to 1 up to r equal to n plus 1. Okay, so if I have a bracket of power n, and the n here is positive integer number, we obtain terms or a number of terms equal to n plus 1. So number of terms here equal to n plus 1. Okay, and here if we look to this general form, we find n combination or minus 1. If we have n combination m, this will be equal to factor of n y factor of m into n minus m, and this is factor. Okay, and here is from combination, as we know before, that n combination 0 equal to 1, n combination 1 equal to n, and here n combination n equal to 1, Another important expression here, n combination to this will be equal to n into n minus 1 by factor of 2. Here, if we have n combination 3, this will be equal to n minus 1, here n minus 2 by factor of 3. Okay, so this is the general form of the binomial expansion. Start here from r equal to 1, which refers to the number of n terms start from 1 up to n plus 1, and here n plus 1 is the number of all terms. Okay, and here special cases or famous cases of the binomial or the combination expression. And here now let me clear that. Let's take our first example here. Okay, x plus y power 3. Let me write this here. So x plus y power 3. Here n equal to 3. So number of terms equal to n plus 1 equal to 4. Okay, let me expand that using this general form. So the first term here are equal to 1. So I have here 3 combination 1 minus 1 equal to 0, and here x of power n minus r plus 1. So here 3 minus 1 plus 1, and y here with power r minus 1. So 1 minus 1 plus, move to next term here 3 combination r here equal to 2. Okay, so 2 minus 1 x of power n minus r plus 1. So 3 minus 2 plus 1, and y here equal to r minus 1 plus 3 combination here are equal to 3 minus 1 x equal as power x equal to n minus r plus 1. So here 3 minus 3 plus 1, and y power r minus 1 plus the last term here is 3 combination here the fourth term. So 4 minus 1 x here power 3 minus 4 plus 1, and y here power 4 minus 1. Okay, let me clear that. Okay, so this will equal to 3 combination 0 from here equal to 1, x here of power 3 minus 1 plus 1. So x here is cubic x plus 3 combination 2 minus 1. This will be 3. Okay, from here n combination 1 equal to n, and x here of power 3 minus 2 plus 1, this is equal to 2, and y here of power 1 plus here 3 combination 3 minus 1. So let me write that this will be equal to 3 combination 2. So 3 into 2 y factor of 2 from here. Okay, into x of power 3 minus 3 plus 1. So x of power 1 and y here power 2. Okay, plus 3 combination 3, this will be equal 1, and x here of power 3 minus 4 plus 1 of power 0, and y here power 3. Okay, let me write that cubic x plus 3x square y plus here factor of 2 is 2. So here we have 3x y square plus cubic 1. Okay, this expansion by using the general form of binomial expansion. Okay, let's move to our next example. Here is if we have x plus 3y power 5. Okay, so n here equal to 5. So number of terms equal to n plus 1 equal to 6. Okay, so here x plus 3y power 5. We don't have here y but 3y, so no room for Pascal triangle here. Okay, just use f the coefficient into the bracket of binomial and both terms equal to 1. Okay, so let's start. Let's write just here first term. Let's expand it vertically. 2, 3, 4, 5. Here 6. Okay, so the first we have here power 5. So the first term equal to 5. Combination r minus 1. So here r equal to 1. Here 5 combination 0. First term is x power 5 minus 1 plus 1. And here we have 3y power 0. Okay, 5 combination 1. Here we have x power 5 minus 2 plus 1. And here we have y and 2, 3. Okay, 5 combination 2 of x power 5 minus 3 plus 1. And here y square 3 square. 5 combination 3 x of power 5 minus 4 plus 1, and here cubic y cubic 3. 5 combination 4 x of power 5 minus 5 plus 1 y power 4, here 3 power 4. 5 combination 5 x power 5 minus 6 plus 1 y power 5, 3 power 5. here 5 combination 0 equal to 1, and here x of power 5 minus 1 plus 1. So here we have x power 5 and 3y power 0. Okay, here 5 combination 1 equal to 5, and here is x power 4, 5 minus 2 plus 1. Here we have y and 3. 5 combination 2, so 4, 5 into 4 y factor of 2 x power 3 y power 2, here 3 square. 5 combination 3, 5 into 4 into 3 y factor of 3. Here we have x squared y cubic y, and here. Okay, let's continue that. 5 combination 4, so 5 into 4 and 3 and 2 y factor of 4. Here we have x y power 4 3 or here power of x is 0, and 5 combination 5 equal to 1, so we have here y power 5 3 power 5. So let's write the final result. So we have here x power 5 plus, here we have 5 into 3, so we have here 15 x power 4 y plus, let me write it here, plus, here we have 5 into 4 pi factor of 2, so this equal to 10, and this 9, so we 90 cubic x y square plus, here we have 5 into 4 into 3, so this 60, and this 6, so we have here 10 into 27, okay, the cubic of 3, so we have here 270 x square cubic y plus, here this equal to 81, and here this equal to 5, 120 by 24. Okay, so here we have 405 x y power 4 plus, the last term here 3 of power 5 equal to 243. Here we don't have x, so y power 5. Okay, let's continue to the next example here. So find the expansion of, here we have x squared minus 2y power 5. Okay, so again number of power of n equal to 5. So number of terms equal to 6. Okay, so again rewrite that here. So we have here x squared negative 2y power 5. We don't have here x, but x squared. We don't have here y, but negative 2y. So here first term, second, third, fourth, 5, 6. And here equal to 5. So here 5 combination 0. First term is x squared power 5 next 1 plus 1 and 2 negative 2y power 0. Okay, 5 combination 1 here x squared power 5 minus 2 plus 1, and here we have y and 2 negative 2. 5 combination 2 x squared power 5 minus 3 plus 1. Here we have y squared and 2 negative 2 square. 5 combination 3 x squared 5 minus 4 plus 1. Here y power 3 power 3. Okay, 5 combination 4 x squared 5 minus 5 plus 1 y power 4 and negative 2 power 4. 5 combination 5 x squared 5 negative x plus 1. Here y power 5 and here negative 2 power 5. Okay, so we have here 1 and 2 x squared of power 5. So we have here directly x power 10. Okay, here we have 5 combination 1, so here we have 5 and x squared of power 4, x of power 8. Here we have y negative 2. Okay, here 5 combination 2, so 5 4 5 factor of 2. Here we have x squared power 3, so x of power 6, y squared and 2 square. Here 5 and 2 4 and 2 3 5 factor of 3, x squared power square. So we have here x of power 4, y power 3. Here 5 combination 4, so here 5 and 2 4 and 2 3 and 2 2 by 4 x squared 5 power 4 negative 2 power 4. Here we have 5 combination 5, so here we have 1 and x squared power 0, so here y power 5 and 2 5. Okay, so let me write the last result here. X power 10 plus, here we have negative 2 into 5, so we have here negative 10, sorry, let me change the sign. So we have here negative 10 x power 8 y. Let's continue. Plus, here we have negative 2 square into this equal to 10. So we have here 40 x power 6 y square plus or minus. Let me know. So we have here 10 here equal to negative 8. So we have here negative 80 x power 4 cubic y. Okay, plus here we have 16 and here we have 5. So here we have plus 80 x square y power 4, and here the last term is we have here negative 2 power 5. So we have here, sorry, so we have here 32 x square here power 0. So we have here y power 5. Okay, let's clear. Next example, here we have 2t minus 1 by square root of t and this power 4. So n here equals to 4. So number of terms is 5 terms. Let me write this here. 2t minus 1 by square root of t power 4, and here first, second, third, fourth, fifth. Okay, so the first term here is 4 combination 0. First term is 2t power 4 into negative 1 by square root of t power 0. Here 4 combination 1, 2t power 3, and here square root t power 1. Here 4 combination 2, 2t of power 2, and here power 2. Here 4 combination 3, 2t power 1, and here 1 by square root of t power 3. Here we have 4 combination 4, 2t power 0, and here 1 by square root of t power 4. Okay, so here we have 4 combination 0 is 1, and here we have this term of power 0. So we have here 16t power 4, and here we have 4 combination 1. So we have here 4, and the first term is 8t power 3, and here we have 1 by square root of t negative 1. Okay, here we have 4 combination 2. So 4 and 2, 3 pi factor of 2. Okay, here we have 4 t square, and here 1 by t. Okay, here 4 combination 3. So 4, 3, 2 by factor of 3, 2t into 1 by square root of t. power 3, and here we have power 3. Here the last term is 1 by square root of t of power 4, so we have here t square. Okay, let's write the final result. Here we have 16 t of power 4 plus, sorry, point to this. So we have here negative, okay, we have here negative 32 of t. Here we have t of power 3, and here t of power negative half. So we have here 5.2. Okay, and let's continue that. Here we have 6, so we have here 24 t. Here we have 4, 24, and here we have 6. We have here 4 and 2, so we have here negative 8 and 2 t. T here power 1 and t here of power negative 3 by 2, so we have here t of power negative half. Okay, okay, and last term is 1 by t squared. Okay, let's move to next example here. And this example want to find the third term from the expansion of 3x minus 1 by 6 cubic y power 6. Okay, here we have n equal to 7, and from this r equal to 3. Okay, so let me find this term from the general expansion. Okay, so here third term equal to 7 combination of r negative minus 1. So here 7 combination 2 and 2 3x of power n minus r plus 1. So here we have 3x of power 5, and here cubic y of power 2 and 2 negative 1 by 6 power 2. So we have here equal to 7 by 6 by factor of 2 and 2 3 power 5 x power 5 y power 6, and here 1 by 36. So we have here is 3, so we have here 21 and 2 243 by 36 and 2 x power 5 y power 6. So this is the third term of this expansion. Okay, we don't have to find all expansion, just use the general form of the binomial expansion, and both are equal to the number of the term in the expansion just to find it. Okay, let's clear that and move to another example. Okay, here we need to find the expansion of here x squared plus 8xy plus 16y squared and this power 4. Okay, just this is slightly different between the last example. Here, if we notice that we can just transform this bracket into x plus 4y squared and all this bracket is power 4. So here we just have x plus 4y of power 8. Okay, here n equal to 8, so number of terms equal to 9. As we done before, just write our binomial here for y. Okay, and just write here from 1 to 9 and apply this general form of binomial expansion to find this expansion. Okay, I hope that is clear. Okay, and thank you.